Today's lesson is going to cover some vocabulary. We're going to do some pattern analysis, and then we're going to make some of our own guesses based on those patterns. You can go ahead and pause to copy down the following definitions. I did try to keep them short. When you're done, go ahead and unpause the video, and then we'll just pick up where we left off. So inductive reasoning is basically when you see a pattern and you make a prediction based on that pattern. So if I said 2, 4, 6, you're probably thinking the number 8. You just used inductive reasoning to make that prediction. A conjecture is basically in math, it's like a hypothesis in science. So it's just when you make a guess, and it could be true or it could be false, we don't know. A counterexample is something that basically proves something wrong. So if I said that all dogs are yellow, black labs would be a counterexample because they're not yellow. A theorem is just a conjecture that is true in all cases. So for example, a negative number times a positive number will always give you a negative number. That is a theorem because it is a true statement. So we're going to look at two patterns that I try to keep pretty simple. So you're trying to think 3, 6, 12, 24, what's going on that I'm getting those numbers? And hopefully you realize the next numbers are going to be 48 and 96 because we're doubling. Similarly, with the picture below, we have 2 slices of pie, 4, there's 6, so there's going to be 8 slices of pie. So you draw a plus sign and you split each section in half, and that makes 8. So we're going to take a step further and we're going to talk about numbers. So I want you to think right here, I'm just going to ignore this part. I want you to think of the first 30 odd numbers. The first odd number is 1. The first 2 odd numbers would be 1 and 3. The first 3 odd numbers are 1, 3, and 5, and so on. So you can see the pattern growing. What they want you to do is add these together, because you see the word sum. So they want you to add these rows of numbers together. So that's what we're going to do really quick. So 1 is just our starting point, so I'll write 1 over here. 1 plus 3 is 4. 1, 3, 5 make 9. 1, 3, 5, and 7 make 16. And so on. So they want you to actually have 30 of these numbers. So I'm not going to write out all 30 numbers. I'm just going to draw a line for that. And they want to know, what's that going to equal? So the reason I'm not going to write all of those out is because I see these numbers and I realize that they're special. So if you don't recognize these, you will see these a lot. These are the first perfect squares. So 1 is 1 squared, 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, and we would just keep on going down the list. So when we had one number, the answer was 1 squared. When I had 2 numbers, the answer was 2 squared. 3 numbers, 3 squared. 4 numbers, 4 squared. So if you had 30 numbers, based on the pattern, we should get 30 squared as our answer, which is actually 900. And if you try that right now, you will see that if you add up 30 odd numbers, just like we did here, you're going to get 900. Okay, so the next example says find a counterexample. That means, hey, these are all lies. Show me, prove to me that this is a lie. Give me an example of something that makes this not true. Any number squared, so let's say 1 squared, is greater than the number. Well, 1 squared is 1. And if I look at this, I realize 1 isn't more than 1. So that's a counterexample. You could also use 0. 0 squared is not more than 0, so that works as well. Any 3 points can make a triangle. Okay, so if I draw these 3 points, however, they do not make a triangle, so that's a counterexample. Any number and its absolute value are opposites. For example, if I take the absolute value of 8, that is just 8. Okay, these are not opposites, so 8 is a counterexample. Same thing with 1, 0, 3. There's an infinite amount. So any of those would be fine as a counterexample. We're going to skip the example 4 here. This was a kind of me get to know the students and their mindsets, so that's really not going to impact what we do in this unit. The last couple questions are patterns that really these two aren't math related, but it's always interesting to hear kids think out of the box. So if you look at these letters M, T, W, T, F, they should look kind of familiar to you. They're actually the days of the week. So we have M for Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Same thing here. These are all words or letters of words that would be in order. So if you think of the months of the year, you have April, May, June, July, August, September, October, November. The last example says make a conjecture about the sum of any two odd numbers. So pick two odd numbers like 1 and 3. And you're going to add them together. So you get 4. Right? We're going to pick two other odd numbers like 7 and 9. And I get 16. We could pick 5 and 3. We could pick, well, let's go with 11 and 3. Okay, so your question is, you're supposed to make a hypothesis about these answers. So what do they all have in common? And most kids are able to figure out these are all even. So you can say it will always be even. Here, and then that's your conjecture right there. That's a statement based on a pattern.